All right, good morning. This is Mr. McColley. This is Pre-Calculus. This is our third Blizzard bag for section 6.3, part 2. Hope you're staying warm this morning, and let's get to it so we can keep it under 20 minutes. All right, yesterday, I'm a little ahead of myself. Yesterday, we started talking about how we're going to use trig to represent vectors and directed line segments, and we're going to perform some basic operations. I was hoping to finish this up today, but I don't think that I'm going to get it finished in under 20 minutes as promised, so I think I'm going to cut this section up into 3 sections, and we will finish it up on our next day back. So, remember just some real quick things, that the component form of a vector, we have these little brackets here that we're going to use to indicate that it is in fact a component, and this is the endpoint of a vector whose origin starts at, or whose tail starts at the origin, is what I wanted to say. Remember, the double lines indicate that it is the magnitude of that vector, and graphically that means that it's the distance. We're going to be using scalar multiplication a lot, and some vector addition today. We're also going to be using the unit vectors I and j, which are just the horizontal vector and the vertical vector. We're also going to be using the unit vector quite a bit. A lot of the questions today that we're going to do are going to shrink a given vector down to a unit vector, and then we're going to use scalar multiplication to get it to be of the magnitude in which we want it. Okay, so let's jump right into it. I'm looking at page 554, number 40, and in page 554, number 40, they say that the magnitude of vector v, so they say the magnitude of vector v is 10, and then they give us the vector u as 2i minus 3j. So they say the vector u is equal to 2i minus 3j. Okay, direction asks us to find the vector v with a given magnitude in the same direction as v. So let's break that down and talk about what they're really asking for in this particular problem. Now, I know that this indication, because this is the horizontal vector I and this is the vertical vector j, we can very easily drop this down and say that the component form of vector u is 2, -3. All right, now what that says is that if I were to map this vector, I would have, I would come over here 2 units and down 3 units. So we could go 1, there's 2 along our x-axis, and 1, 2, and 3, -3 along our. Now this vector here is not 1 unit long. I don't know how long it is, and I could use the Pythagorean theorem to find it, but we want a vector that's in the same direction as this vector, that is not whatever length this is, but 10 units long. So essentially what we're going to do is we're going to use this process of finding the unit vector to find a unit vector that's 1 unit long, and then we're going to use scalar multiplication to make it 10 units long. So getting right back at it, what we're trying to do here is essentially what we're going to do. Let's see if I can't find let's make it a little bit smaller. I only want my thickness to be this, and I want it to be that just for now. Okay, what we're going to essentially do is we start with this original vector. We're going to shrink it down to a 1 unit vector in the same direction, and then we're going to use scalar multiplication to put it in the same direction, except that final vector is going to be 10 units long. Okay, so the unit vector, and I'm going to just do a W, call it W for right now, is going to be 1 over the magnitude of this unit vector, which is going to 2, -3. And so that's going to be the square root of the sum of those two values squared. So the square root of 2 squared plus -3 squared. And so I have 1 over the square root of 13 times 2 times negative 3, which will give me, let's see here, just real quick, I distribute the 1 over square root of 13, and then I multiply by square root of 13 over 13, which would give me 2 square root of 13 over 13, comma, negative 3 square root of 13 over 13. Now this is the unit vector. So what I've done is I've taken this original vector here and I've shrunk it down to a vector of 1 unit length, but it's still in that same direction. Now I'm going to use scalar multiplication to make that vector 10 units long. So I'm just going to go 10 times 2 square root of 13 over 13, comma, negative 3 square root of 13 over 13. It's going to multiply by 10, and my final answer is going to be 20 square root of 13 over 13, comma, negative 30 square root of 13 over 13. And I wish I could reduce that, but there's nothing in there that reduces. So that is my vector. That is the same direction as my original vector, except it is now 10 units long. All right. Okay, moving on. Next one. Same page, number 48. In number 48, they say the vector v is equal to the, let's see here, u minus 2w, and they say that u is equal to 2I, let's see, make sure I get it right, minus j, and w, that vector, is equal to I plus 2j. And what they're asking for is they want the component form of v and then sketch the specified vector operations geometrically. Okay, so the first thing we want to do is, well, I'm looking at this, I'm going to change this to component form. And so real quickly, since it's 2i and minus 1j, I'm going to get 2, negative 1. There's the component form from these unit vectors. And then w, it will be 1 plus 2j. And so here, what we're trying to do is, if I know that u is this component vector, I'm just going to go 2, comma 1, like that. And then this one will be minus 2, and then vector v, we said, oh, I screwed that up, didn't I? Sorry about that. That's wrong. I just copied it. It should be 1, comma 2. That should be it. There we go. 1, comma 2. And so first thing I got to do is I distribute this, distribute the 2 to those two values. So I've got 2, comma negative 1 minus 2, comma 4. And now when we are subtracting vectors, we subtract the individual components. So I would have 2 minus 2 is 0, and negative 1 minus 4 is negative 5. I think my math is correct on that one. So that is the algebraic version. And let's see here. If I wanted to do it, let's get a line here. Let's see here at 0, negative 5. Let's see. Okay. I just want to make sure that I hit everything here. Oops. Let's go back to it. All right. 1, 2, 3, 4, 5 on the x-axis. 1, 2, 3, 4, 5 on the y-axis. And 2, negative 1. So my first vector here, excuse me, 2, negative 1. So I go out 2, down 1. There's my 2, negative 1. And then I'm subtracting away from that 2, 4. So I'm really taking a vector that's going to go back 2 and down 4. So this vector, I subtract that away. I start at that one. I go back to, oh, come on, go back 2, down 4. And so my resultant vector is that one right there. Make an arrow. There we go. That's where I get that. All right, moving on. Number 50. Number 50 says, find the magnitude and direction of the vector v. And so in number 50, they give us v, the vector v is equal to 6i minus 6j. So 6i minus 6j. And so they want the magnitude and the direction. So essentially what we're looking for is we're looking for this angle right here. If this is positive, well, that's not right. It's not even close. I don't know how I set that up that way. Sorry about that, folks. Let's get it right. Just move it up so we can see it all. There we go. So 6i minus 6j would be the vector 6, negative 6, just like that. And so if I drew in this vector, this would be positive 6 right here. This would be negative 6 right there. And we're trying to figure out this angle measure right here. Now, unfortunately, if we think about it in terms of a right triangle, this right triangle right there, if I know that this is 6 and I know that this is negative 6, what we're going to end up doing is finding out this angle. Now, that's fairly simple. I've got an angle theta here. There's the opposite side. There's the adjacent side. And so I can say that the tangent of theta is equal to, let's see here, opposite negative 6, adjacent positive 6. So theta equals the inverse tangent, the arctangent of negative 1. And we all know that in as far as the unit circle goes, that's going to be negative pi over 4 or negative 45 degrees, because of the fact that arctangent only goes from pi over 2 to negative pi over 2. So we only have that. So we just have to do a simple little calculation to get this. So our angle, the easy part, if I go 45 from 365, I'm at 315 degrees. There, 350, come on, McColley. 315 degrees. That is my angle. And then they want the magnitude of that thing. And remember, the magnitude of V is just essentially the Pythagorean theorem. So 6 squared plus negative 6 squared, which ends up being I've got 36 and 36. And just to keep it easy on myself, is 2 times 36, which is 6 square root of 2 is my final answer. If you have questions on that, you can ask me a little bit, or ask me in class when we get back. But that's pretty straightforward, and you can figure that out, I'm sure. All right. So the direction and the magnitude, number 50. Okay, here is the assignment. For those of you who have made it this far, here's what you do. You email nat.mccully@omarisa. You type your name in it, and you type "I watched it" in the subject bar, and I will count you off. And that's it. Okay, finishing up here. I think I have one, maybe two more. Got 2 more. We're on number 58 on that page. It says find the component form of V given its magnitude and its angle mixed with the positive x-axis, and then sketch V. Okay. So essentially what we're going to try and do here is they say that number 58 that we want an angle or a vector V with magnitude 9, so we want it to be 9 units long, and then we want it to have an angle from the standard position of 90 degrees. Now this one is fairly easy, fairly straightforward, because we know 90 degrees. If we start, oh, that's not very good. Let's get the right one. So if we start with any vector, if we start with any vector and we go 90 degrees, well, that's just straight up and down. So this one's fairly easy. We can just kind of figure it out to be 0, 9. All right. But if we were to break this thing down into its component parts, remember, a 90-degree angle would be, we could calculate that value by breaking it up. We would go the sine, or excuse me, the cosine is the x value. Let's do it right. The cosine of the angle theta times the I, that's j, times the j function, comma, the sine of the theta times the I, or the j, the vertical unit vector. That's what I wanted to say. Okay, so essentially, if we do 9 times that, we're going to end up with this. And then so the cosine, and so 9, the cosine of 90 degrees times the I vector, and the sine of 90 degrees times the j vector. We would get 90 times, okay, I is 1, 0. And so the cosine of 90 is 0, so I would get 0. And then the sine of 90 is 1. And then so j times 0, 1 would give me 1. And so when I multiply that out, I get that as my final answer. All right, last one. I think I can get it done here. Number 62. Essentially what it says is find the component form of the sum of u with v in those two vectors. And so we're trying to find this sum. We're trying to find v plus u. And in this particular case, they say that v is an angle that is, let's see here, it has, v has magnitude of 2, and it has an angle of 30 degrees. You know what, let's make this v equals 2, and then it has a theta for v of 30 degrees, and then u also has a magnitude of 2, and its angle is 90 degrees. All right, so I'm going to figure out the component of both v and u. And so just like we did in the last one, we're going to say that v is going to be 2 times the cosine of 30 degrees times the I vector plus the sine of 30 degrees times the j vector. And we're going to say vector u is 2 times the cosine of 90 degrees of the I vector plus the sine of 30 degrees plus the j, 30. I was just copying above. Sine of 90 degrees of the j vector. All right. And so the cosine of 30 is square root of 3 over 2. And the sine of 30 is a half. So I get 2. This thing becomes square root of 3 over 2, 1/2. And then this one is cosine of 90 is 0, and the cosine and the sine of 90 is 1. And so I end up with, this is v, this is u, and so v plus u ends up being square root of 3, comma 1, plus 0, comma 2. And I get those values when I distribute the 2 to these two. It cancels out the bottom part, so I just get square root of 3 and I get 1. When I distribute the 2 to the 0, I get 0. Distribute the 2 to 1, I get 2. And so my final solution here is going to be square root of 3, comma 3. And you can see that if I go out this distance here, which would be square root of 3, and then this is going to be 1, and then I've got another vector that's 2 units long. And so 1, 2, 3. My resultant vector, this one right here with a big arrow, is going to be square root of 3, 3. That is the end, folks. I hope I kept it just a little over 20 minutes, and I apologize for that. So I'm going to end it right here to keep it short. If you have questions, just leave a comment in the section below. Goodbye.